Why are acids? What defines them? Why do we care about acids so much? But most importantly, how can we make an acid from an acid, from an acid, from an acid? Well, in this completely safe Make It tutorial, I'll show you exactly how it can be done. But first, we need to start with an old classic.
Yeah, making sulfuric acid. Now, I've already done this on this channel before, twice, so I won't spend too much time on it, but here's the basic idea. We start with copper sulfate. Copper sulfate is a salt, meaning that there is an ionic bond between the copper and the sulfate, which is just a bunch of smart words I chucked in there to make myself feel really smart, but it basically means that this is positive, this is negative, and opposites attract. Congrats! It's a bond. Now, ionic bond is a curious thing. So far on the channel, I've mostly discussed bonding due to orbitals, which follows different rules from the bonding due to charge. And so basically, if we want to break it, all we need to do is just give it some charge, which we can do with the electrons. That's why the cables are there. And now you've just got to know I'm gonna hit you with a time-lapse like... Oh, that's a good time-lapse. I mean, oh, the color change? Mwah. Anyway, we chuck in some electrons at copper, it's no longer positive, and so it just accumulates on the wire. Great. Now, as it just so happens, on the other side, we're electrolyzing water and getting some extra hydrogens. Hydrogens which, when combined with our sulfate, create, drumroll please, a mess. A big old mess. It's a real big mess. And I guess some acid in it, right? Like sulfuric acid, that's kind of convenient. Okay, but why is sulfuric acid so fun? Well, apart from being rather tasty...
For legal reasons, I should mention, it is dangerous to drink sulfuric acid. Do not drink sulfuric acid, okay? Don't drink it, it's dangerous. Even though it tastes really lovely, it's like sour sweet sauce with a hint of lemon in it, it's really delicious. Don't drink it, okay? It's dangerous. It's dangerous to drink sulfuric acid.
Acid is mostly really fun because of this. This is its electron density, and what it basically means is that we have more electrons in the center, clustered near the sulfur, than near the hydrogens. And in this case, you can think of the electrons as glue that holds the entire molecule together. So if in this place you don't have quite as much glue, then the molecules there aren't attached quite as strongly, meaning that these two hydrogens can rather easily detach, even leaving their own electrons behind. Meaning that this sulfur-based molecule is really good at detaching their hydrogens. So it's a sulfuric molecule with loose hydrogens, so like a sulfuric acid. Yes, that's the defining characteristic of acids. Basically, there are two kinds. Either acid that is fine with losing positivity, or fine with gaining negativity. Both of these are kind of the same thing if you think about it, like losing positivity, that's kind of like charge minus plus 1, because losing positivity, gaining negativity is kind of like plus minus 1, so gaining negativity. That's acids, respectively Brownstein-Lowry acids and Lewis. The opposite of that would be bases, and there we go. Acids are the ones that lose charge, bases gain charge. Lowry do it through protons, Lewis through electrons. Now, the reason why these are important is because, as we've previously discussed, all of chemistry is based in electromagnetism. And I guess some funky electron quantum mechanics stuff, but I've already explained that in the previous video, so I guess. And so certain molecules being able to attack with purely positive charge or accept purely negative charge kind of matters. Where would that matter? Well, imagine this. Here we have some table salt, sodium chloride, and you won't believe it, but it's made out of sodium and chloride. Both of these are ions, which means that they do have net charge. So sodium is more positive, chloride is more negative, and there, they hold together like a magnet. Not because of funky electron orbitals, only because of charge. Hold on, make it. You mean to tell me that we have this salt, which is bonded due to positive and negative charge, and we have this molecule which can easily add in positive charge, then what's gonna happen when we put them together? And I'm so glad you asked. You take the salt, you pop in some positive charge, boom, breaks the chloride apart. What's more, this single proton can be thought of as just a positive hydrogen ion, a cation if you will, and so our chlorine has 2 negative of a charge, hydrogen has 2 positive, and they bond. Now, because chlorine had all the electrons and the hydrogen was basically just, well, a single proton, the bond is really unequal, and most of the electrons are still near the chlorine, but don't worry, you don't have to think about this too much, that's only foreshadowing. Anywho, the other side of our crystal is sodium, which bonds with the remaining sulfate like so. So, to summarize, in our reaction we start with the salt, then we introduce the acid, which breaks it away into two new molecules, which will totally not be relevant later on. And now with that in mind, we can see how this reaction would occur in real life. Wow, that was certainly underwhelming, but don't worry, it released a bunch of really toxic gas into a not ventilated room, so at least that's good, you know? And that's all there is for now about acids, but there is one more thing we need to do before we actually get into our tutorial, and that is distillation. If you've tried doing what I've done so far, it wouldn't actually work. That's because you need a much more concentrated acid, so how would we concentrate it? Well, that's easy. Sulfuric acid has a higher boiling point than water, so if we heat it up to the point where water starts boiling, the water will boil away and the acid will be left behind. Honestly, I could go more in depth and explain the differences between the intra and intermolecular interaction, but let's be honest, this is meant to be a silly practical video, so instead I'll just play this time lapse of me boiling it away. Okay, cool. Now, the boiling away process is pretty simple, but I still wanted to mention it because in most of these reactions, just adding the acid isn't enough. That's because this isn't our reactant and this isn't our product. This is our funny liquid and this is our garbage. And what we want is to get rid of the garbage and only keep the funny liquid. So how? Well, that's distillation. The basic idea is really simple. If we have water mixed with sulfuric acid, then we can just boil it to evaporate the water away and be left with sulfuric acid. Simple. If we want to reverse the process, however, then we use distillation. So we evaporate the water away, then we condense it, and then we get it back, leading to a separate container with water and separate with acid. This is especially convenient because right now we have a way to divide the product in which this is the difference in their boiling points, and a way to divide the product if this is the difference in their boiling points. Distillation works for both.
And so yeah, distillation is actually pretty simple on paper. In practice, it's way more annoying, and I mean way more annoying. And whilst, yeah, I do chemistry, you know, on the weekends, I'm not much of a chemist myself, and I don't really have a distillation set, a professional distillation set. Without the distillation set, this will be borderline impossible to do. And so, actually, I guess that's it. I guess we just can't distill it. I mean, it's not like I can just get a distillation set and have it right here in the literal next frame of the video. I got the distillation set. It was so expensive. Shout out to my Patreons. Because this is a month's worth of Patreon money. Just this glassware, not all the other things I'm gonna bring up. Okay, so at this point we got the setup, and right here we have the distillation set. One problem, however, and that problem is in the form that this isn't exactly working. This pump just, well, it's not the right kind of pump for this. It doesn't feel strong enough, I don't have the proper way to hook a cable to it, and so on and so forth. Which is actually a pretty big problem. And I mean, it's not like I could just, you know, get a whole separate water pump with the literal next frame of this video. So I got this water pump, and yeah, if any of you are wondering, make it, what if this plastic will melt? Well, I'm wondering that too.
The reaction we'll do is pretty simple. We'll just take some vodka, we're gonna distill it to get some ethanol and kind of water or whatever's left there.
Okay. First we're going to start simple. Just a test to see if this works. So in order to see if it works,
We just need to plug it in. What could possibly go wrong, am I right? Okay, it kind of works. Alright, not quite, but almost. Okay, 60. We might be getting there, so I feel like for the sake of safety, we should plug in the jets. Oh, that's such a good idea. But, okay, so hold on, stop, no, stop doing that, listen, hear me out. What if you just stop doing this, okay, because no one wants this, there, okay, keep yourself up, mate, look up, life isn't so bad, there. I think I need these. It's beautiful! Well, we did it. And honestly, with this perfect setup, how could we not? And so now one last thing to do would be to just check if our distillation worked, to see if we got ethanol from vodka. And there's only one proper way to do it. And so there, the distillation worked, which means that now we can use it to get to the actual experiment of the video, the actual reason why this video is made in the first place. And in order to do that, we'll first take some sulfuric acid, then some sodium nitrate, and then react them together and distill. Should be simple, right? Pour in some sodium nitrate, here pour in some sulfuric acid, right there, then heat to over 140 degrees Celsius, then let it go on and compress with nitric acid. For each 98 grams of sulfuric acid, we need 85 grams of sulfuric acid, except with sulfuric acid, it's not 100%, not close. That should be close enough to going. And one last thing is the fact that we'll be dealing with some pretty, well, let's just say undesirable gases. We basically want to condense as quickly as possible, so we'll need some ice. Now, I didn't prepare any ice, so I kind of forgot. It was a bit of a problem. For the previous one, we were just fine with cold water, but for this one, we... Oh, you know what? I have an idea. This could work. I mean, it's not like I'll just have some ice in the literal next frame of this... This power is not to be trifled with. Then, after a quick break of mixing every single acid I've got, electrolyzing it even more and concentrating it, it was finally time to do some actual professional chemistry. I mean, okay, I'm doing the best I can with the resources available, alright? That right there is red. Now, red is really good, because that most likely means it should be nitric acid. However, I wasn't able to test it, which means that I don't actually know if it was nitric acid or not. I am really sorry to leave you with such a kind of annoying conclusion of this experiment, but I just simply do not have the means to repeat it, nor do I have the means to carry it on. And so yeah, unfortunately, we'll never know if I actually made nitric acid. But what I did definitely make though was basically a splash potion of instant damage. And so yeah, the experiment ended up being a bit of a failure. Technically, I probably made some nitric acid, but in reality it was so impure it didn't even matter. And so that's why this video has been sitting on my drive for 6 months actually. But anyway, now it's finally time to get into the conclusion. All the reactions you've seen today may have seemed a bit disconnected, random, unrelated, but let's take a look at them again. First, we take the copper sulfate, we add in protons, and the salt breaks, we got an acid. Then we took sodium chloride, we added in sulfuric acid, and the salt breaks, we get an acid. Then we took sodium nitrate, we added in sulfuric acid, and the salt breaks. We get an acid, and this pattern is no mere coincidence. That's because you can think of it this way. With Lowry acids, a perfect acid would be just a single proton. A perfect base would be a hydroxide. If we combine them, we get water. If we separate them, they both need to bond to something, and when they do, that creates an acid and a base. If we let those acidic basic parts go, however, we get a salt. The simple circle of Lowry acids. Now, if you look back at all the reactions we've done today, you'll see that each time we took a salt, we added an acid, and we got back a different acid. Acid from an acid, from an acid, from an acid.
This is actually really simple. It's a lot simpler than it seems, and that's because all you need to do is just take a salt, add in an acid, separate the new acid, and repeat. But the actual reason why I'm making this video isn't to teach you what are acids or how to work with acids. No, the actual reason why I'm making this video is because there's this question that's always been bugging me before I understood what acids are, and that is, why are acids? You see, acids are wildly different molecules. Even the general Lowry rule of thumb breaks away once you get to the Lewis acids with no hydrogens. So, what combines them? What ties in the entire concept together?
And that is the fact that really often in chemistry we do care about what molecules react, but sometimes we don't need any specific molecule or any specific group of atoms. Sometimes what we need is just for this mysterious molecule to accept an electron or donate a proton. And that's when you just need to use an acid. Some acids will work better than others, and yes, there are exceptions, but sometimes the kind doesn't matter. And all that matters is that it's an acid, a salt, and then you get an acid. And that's how you can make an acid from an acid.
From an acid. From an acid. But yeah, first, before we finish off the video, you know there's gonna be a thanking segment. Acronymus, Useless, Quasar, and Lagobear. Thank you all so much for being highest tier patrons, and thank you to all my other patrons for supporting me. I really wouldn't be able to make these videos. I can't make them if it wasn't for your support, so thank you so much for that. I'm finally glad to put this big slug of a video behind me and move on to the new stuff, like the projects that for now are a secret and Patreon only. And then there is the art. Thank you so much, Tha, for this lovely art of drunk me jumping over a bear, which honestly, the idea for it was on a live stream, and I wish I could give you context, but it's kind of a long story. And then also to you, Positron, for this absolutely lovely nah, screw it, I approve. I also stream every single day a series of live streams called Charity Checkup, which we stream for charity. Right now we're collecting money for charity Prevent Cancer Foundation. Would recommend, it's a lot of fun. And I have a Discord server, I have Patreon, I have all this other stuff, which you already know about. And for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.